Hello, everyone. Welcome to today's webinar. My name is Javier Ortiz. I am your mentor throughout this program, Data Engineering Nano Degree by Udacity. So I'm really excited for you guys because we are about to start our last project, Data Pipelines with Airflow. All right, so let's get right into it because I have lots to cover today. So let me open the project itself. And let me share my screen with you guys. All right, so this is part 5, data pipelines. And once again, music streaming company Spotify wants to introduce automation and monitoring to the data warehouse. And they're going to do it with Apache Airflow, and they want to create high-grade data pipelines, dynamic, built for usable tasks. All right, so their source data resides in S3, and it needs to be processed in Sparkify's data warehouse in Amazon Redshift. And it's CSV logs, are CSV logs, and JSON metadata. All right, metadata. So we have two types of files, and we have it in S3. We need to stage it in Redshift, and then we need to create our dimension and fact tables. All right. So this is the basic pipelines that we're going to create, the DAGs. So we're going to start with a dummy variable, the dummy operator, begin execution, and then we're going to stage events and songs simultaneously. So we're going to stage those tables at the same time, and from there we're going to load simultaneously into a song place fact table. From the fact table, we're going to load the different dimension tables. Then we're going to run the data quality checks, and then we're going to end execution. All right. So as you can see here, we already can figure out what sort of operators we're going to use. We need a stage operator, which is basically a stage from S3 to Redshift. And we're going to use that operator twice. We're going to use it once for events and another one for songs, all right? So that's one operator we're going to use. Another operator we're going to use is the long someplace fact table, which is the load fact table, which is going to take our data from the staging tables to the fact table. So that's the second operator we're going to use. And the third operator is going to load from fact tables or from this staging tables into our dimension tables. And our last operator is going to run the data quality checks. So it's 4 operators in total that we need to incorporate here. All right, so this part tells you how to add your connections to Airflow. It's simple, but it can get tricky. So let me walk you through it. Right, let me split my screen. All right. Okay, so it says go to Airflow, and let me first, before you can run your workspace, you need to run this code at the terminal provided there. So you can find the code in step number 5, workspace instructions, and it says, and it's this line over here. You just copy and paste it over here and enter, and then you should be able to see Airflow loading here. Takes a second or two. Let's wait it out. A couple of seconds more. All right, and then we can access Airflow. Cool. So let's follow the instructions to add Airflow connections to WS. So it says click on the admin bar right here. Let me move my face out of the way. All right, and select connections. Once you're here, you're going to select create, And here in connection ID, just name it AWS credentials because that's what we're using throughout the DAG. And connection type, Amazon Web Services. Then login, here goes your access key ID from the IAM user, right? So these you get it from your IAM user at your AWS account. You can download it there. So put it there. And here in password goes your secret access key, which you get from the same place. Once you have done that, you're going to save and add another connection. And it will basically take you to a page which is the same as this one. And this time we're going to connection ID, we're going to name it Redshift. And connection type is Postgres. And host, you're going to add the endpoint of your Redshift cluster, right? Excluding the port at the end, right? Please make sure not to include the port at the end of the Redshift endpoint string. Where can you find this endpoint? Log into your AWS and go to Redshift, and you should see, you create a cluster, obviously, and you should be able to see it there. Schema, this is the name of your database. If you're creating the database following these instructions, I mean the instructions that were given to you in previous units, I mean, they're using this default names, so it might be a good idea to keep them just to not get confused. But the name of the database is dev. If you name it differently, use that name. Then login is the name of the user. If you use another user, use that one. And then the password that you use to set up this database. And finally, the port, which is the default port for all things Redshift. Let's try to stick to that one. And once you have that, save it. I mean, here is the endpoint in Redshift, the port, the database name, and the master username. So you have all this info here. Just make sure this match. If you have different database name or master username, use that, right? And that's it. Yeah, you have created the Redshift connection. So it's pretty straightforward. Cool. So that's the first part of the project. Let's keep going. So project instructions. All right, so you have two S3, one for the log data and the other one is for the, I mean, this is the same S3, just two different folders inside that. All right, so the project has, all right, let me show it to you. So you have the DAX folder. Here you have the DAG template, and here you're going to import and you have all the in-person task templates here, right? But we need to set the dependencies. So this is like a skeleton, and you need to fill it up. And then we have for the operators, you can find those here inside plugins, inside operators. And here are the 4 operators I was talking to you about that you're going to finish. These are just the templates. You have the data quality, low dimensions, low fact, and stage redshift. And you even have some instructions over there. And finally, we have inside the plugins, we have the helpers, and you have a SQL queries, which you're going to take from this class the different inserts for your tables. Cool. So it says with this template files, you should be able to see the new DAG, and this is the graph view, and you should be able to run it successfully, but operator not implemented, right? So in configuring the DAG, you're going to add this default parameters, not have dependency in past runs, unfair task the task are retried 3 times, returns happen every 5 minutes, catch up is turned off, and do not email on retry. And finally, we're going to follow this logic for each of the tasks, right? So you need to build 4 different operators that I already talked to you about, and you can reuse code from project 2. Remember to use airflows, building functionalities, and hooks as much as possible. And the operators will run SQL statements against rigid database, but use parameters wisely. All right. And it talks to you about the stage operator. And it should be able to load any JSON and CSV formatted files from S3 to Amazon Redshift. And the operator creates and runs a SQL copy statement based on the parameters provided. The operator's parameters should specify where in S3 the file is loaded and what is the target table. And the parameters should be used to distinguish between JSON and CSV file. And allows it to load timestamp files from S3 based on the execution time. And then we have the fact and dimension operators. So most of the logic is within the SQL transformations. Define a target table. So are often done with truncate insert parent, where the target table is empty before the load, and data quality operator to run checks on the data itself. And okay, so that's basically it. So let me walk you through it. So this is how, oh, sharing is paused. Let me share again with you. All right, so this is how you get the, well, this is what you receive originally. So as you can see, well, you need to uncomment this. And here in the default args is where you're going to place all the different parameters that they mentioned here. Or talked about here, configuring the deck. Then now dependence on the pass run, on failures, or try this many times. So this goes here. And this is already written for you. Okay, here obviously you are missing some parameters depending on how you set this up on the operator file. The same for this one. Basically all of this, they are missing all the parameters that you're going to set up at the operator's file itself. And obviously here at the end, you're missing the logic of how you want to run different tasks, all right? So this is what you have to do here in this file. So most of the work will be done in this, in the data quality, the load fact tables, log dimension tables, and the stage redshift, right? So for example, your data qualities, you need to define your operator's params here, and it gives you an example. And then you're creating the object, and you need to map the params over here, and implement any logic that you need to follow along here. And the same for this one, for the load facts, and the stage redshift. So they give you a skeleton. The most important thing is you have to define your parameters, map your parameters here, and execute any code you need to use over here to implement the operator itself. All right. With that being said, let me, last thing, this SQL queries, you need to familiarize yourself with them because you are using these to populate your different tables. All right. And okay, so let me go to the solution really quickly and just to walk you through it. Hopefully things will make more sense. 1 second while I open the files. All right, I think I'm ready. Right. So you might like to start with the different operators. I think it's easier that way. So let's start with the load fact, which is the first one that, no, the stage redshift, which is the first step you're going to use. So here we have defined the different params, and here they are. So we need a connection, we need a table name, and which is where we're going to load the things in Redshift, an S3 bucket, an S3 key, which is basically where we're getting the data from, delimiter, header, code chart, file type. If it doesn't specify, it's going to be a CSV, and your AWS credentials. And here you map all of this. And here the logic is really simple. Basically, you're getting a connection to Redshift. Don't forget that. We're deleting the table, which you're going to name it here. Then you're going to specify a path, which is the bucket and the key. And you're going to write a copy statement that you're going to copy that you're going to copy into this table from the specific path, and you're going to access it with the key and the secret, right? And you need to implement a logic. If the file is a CSV, the delimiter is going to be this, and the ignore header is going to be this, and the CSV code is going to be this. So all of these are parameters that you already established. And if it's a JSON, just JSON auto, right? So that will give you as a result in full copy statement, the copy statement along with either this part of the code or this part of the code, right? And then you just run the full copy statement, and that's it. And one thing that is worth mentioning here at the table is that you're going to load into stage events. Now, this table has not been created yet, and in the requirements, it doesn't say that you need to include it into the SQL statement. So what you can do is create that, and where is that? You can create that table straight into Redshift. So you have a create tables file over here, which is different from the SQL queries. And here you have some code to create the staging events and to create the staging songs. So you can just copy and paste this code into Redshift to create those tables, so that when you load this these tables with the info in the S3, these are already created. Otherwise, you're going to get an error because the tables you're mentioning to load the data into doesn't exist yet. They don't exist yet. So make sure you do that. And well, that's it for that operator, all right? And you're going to use it twice, that operator, for the stage events to Redshift, for the stage events, and for the stage songs. All right. So the next one you might want to do is the load fact. This needs less params because most of the logic is in the SQL statement. So you just need a connection to Redshift and the name of the table where you're going to load the data, and map the params, and then make the connection. And the SQL statement is really easy. Insert into, then is the name of the table, and then you're going to borrow the SQL statement. This here in the main deck, the SQL statement, you're saying that you want from this class SQL queries, you want to grab this specific insert. So make sure you map it to the correct one. For example, the song play table insert will borrow from this one, right? As you can see, we get from select, ahead from select, and the rest of the code is there. All right, so that's why you don't need to implement as many things here, and you just need to make sure to run the SQL statement, and you can add these phrases which are really useful, and I suggest you do. Cool. Now for the dimension table, exact same thing, but here in dimension tables, as it was said in the requirements, they usually deleted first, or you're given the option to append to it or delete it first. So that's why we have here an extra param. If it's false, you want to delete it and insert it again into it anew. But if it's true, you're just going to insert it into it. But it follows the same logic as a load fact table. So yeah, most of the logic is already in the SQL queries. And finally, you have the data quality, which you are going to, the params are just the connection and the DQ checks. Now, the DQ checks are, as you can see, are implemented right here. So if you give it 1 or 2, basically these are dictionaries where you're going to extract the check SQL and expect a result. So, no, that's not the one. This is the one. All right. So here, for example, the way you can execute it for check in self DQ checks, or getting the check SQL. So this one would be the SQL query, and this one would be the expect result. And we're getting the records from, and oh yeah, so we are running the query, and if the expected result is different from what we got in the query, the error count goes up, and then if error count is more than 0, tests are fail and data quality checks are fail. Otherwise, data quality checks pass. So it's really simple. You just run the SQL query and you just are adding the error count. And that's it. All right. And don't forget to have, I mean, you already have your dummy queries. Don't forget to incorporate the logic of how you want to run this. So based on the diagram, both stage events and stage songs run simultaneously, and they're going to load into song place table. And from song place table, you're going to load all the different dimension tables, and all of them can go to run quality at the same time. So you're really utilizing parallelism here. And that's it. That's the project. I mean, it's not an easy project. The main DAG is not as difficult because you just, I mean, the only tricky part is all these default arguments and making the connection to your AWS. But from that, apart from that, just making sure that you have all the params here that you specify in the operators, which is the difficult part, but the one that I already helped you with. What operators do you need to make this run? And you have 4 operators, and just make sure you have all the params and that your execute code has a correct SQL code in it, and that's basically it, right? So if you have any further questions about the project, don't hesitate to ask for help. And I mean, it's your last project, so let's focus, let's get it done, let's learn from it, and then we're going to start with the capstone project. All right, so congratulations for coming all this way from the beginning to this point where you're almost done with the program. I know you've learned a lot, and once again, if you have any questions, don't hesitate to ask for help. Right? See you around. Bye.